Alright guys, so we are looking at Algebra 1 through Algebra 1-3, and this is going to be pretty much review of Algebra 1 concepts. So hopefully nothing here is brand new and everything you will see is something that you have done before. The first thing that we want to do is look at the classifications of the number system. So we have real numbers, which include rational numbers and irrational numbers. We will get into complex numbers in a later chapter. So within the rational numbers, there are integers, whole numbers, and natural numbers. Natural numbers are the most elite, the most specific, and those are also known as the counting numbers. So 1, 2, 3, 4, 5, so on and so on. Okay? So the natural numbers are your counting numbers, which can you count on. The whole numbers are going to be all of the natural numbers plus 0. So I'm going to just go ahead and do that. So it's the whole numbers are 0 and the natural numbers. Integers are going to be everything that is in the whole number box and its opposite. Now 0 does not have an opposite, so we would have -3, -2, -1, 0, 1, 2, 3. And that goes on to infinity in both directions. Okay? And then finally, we're looking at the rational number classification. This one is going to be the most inclusive. It has all of the natural numbers, the whole numbers, the integers, and it has numbers that can be written as a fraction, and specifically those that can be written as a fraction, and when they're written as a decimal form, they are either terminating decimals or the repeating decimals. So 25/5 is a rational number. The square root of 49 is a rational number. 1/2 is a rational number. 1/3 is a rational number. I don't know why I'm just doing positives. -3/4 is a rational number. So those all represent rational numbers. Now, irrational numbers is when your decimal representation does not terminate or neither does it repeat. And we also have special numbers that are irrational numbers. Pi is the most famous irrational number we have. The square root of any non-perfect square number will always be irrational. So we've got that. So 1/17, that's irrational. There's lots of other different numbers. Okay, but those would be your classifications. Now, if you're looking at that from an assignment perspective, a test question, then looking at 8 we can count it on our fingers. So that would be a natural number, that would be a whole number, that would be an integer, and that would be a rational number, right? Now, I should write those numbers out because does that R stand for real or rational? Does this I stand for integer or irrational? So instead of just doing I and R, I'm going to go ahead and do INT and RAT. So that's for integers and rationals. 11 is not a perfect square. Now, if I don't know this, then I can put it into the calculator and it's going to give me a display screen of a lot of numbers. So this is irrational, but we know that without using a calculator because 11 is not a perfect square. -2/3 is -0.6 repeating. So this is a repeating decimal, so therefore it is in the rational number system. -100. Well, it's not something I can count on my fingers because it's a negative number. It's not 0, but it is an integer. And if it's an integer, then it's also a rational number. Okay? All right, so now let's take a look at what it's asking us to do for 5 through 8. Graph each real number on the number line. Okay, so 11/4. If I do not know what the value of 11/4 is in decimal form, I'm going to focus that, then I could use a calculator, and that's going to help me get the decimal value, which in this case would be 3.75. 3.75 is, let's see, right? Oh, I apologize. It's 2.75. So that's going to be 1, 2, 3. It's going to be right here, and this is where A is. Pi is approximately 3.14. This is 3. That's 3.25, 3.5. So that 3.14 would be right about there. The square root of 3, when you put that into the calculator, is approximately 1.7. I'd have to think about that number again, but I know it's 1.7-ish. So then that's going to be right about here. And then negative 0.9 repeating. So I'm going to go to the left. Well, for heaven's sakes, I didn't even notice that you guys couldn't see the number line. So I apologize. So let's talk about that real quick. 11/4 is 2.75. So we go 2, and then these are broken up into 4 pieces. So that's 0.25, 0.5, 0.75. 3.14, so it's at 3, and again these are broken up into 0.25 increments, so that's going to fall right about there. So that's why I have the B here. The square root of 3 is 1.6, 1.7. I forget exactly what that is off the top of my head right this second, but I know it's rounded to 1.7. So then that's going to be right on the left of this mark because that's 1.75. Negative 0.9 repeating means I'm going to go to the left of my 0, and that's going to be really super close to -1, but I'm going to be to the right of it, and then that would be my D point. Okay. All right, looking at 9 and 10. These are just comparing them, so use the calculator or use your reasoning logic. This is 9.6, and I know that that's going to be close to 10 because the square root of 100 is 10. I am going to have to use my calculator because I do not know what that is off the top of my head. And so the square root of 95 is 9.75. And so this one is bigger than this one, so I put the symbol like that because this is 9.6 is less than 9.75. 11/2 is 5.5, and then, excuse me, the square root of 28 is going to be 5.29. Well, 5.5 is greater than 5.29, so I use that symbol. Okay, now let's flip it over to the other side. These are the properties, oops, I forgot the top part. But we are going to look at the properties of the real numbers here in just a second. So using these as classification, I'm going to talk through them. I'm going to fill them out, and then I'm going to talk through them. All right, but before I do that, the opposite of an additive inverse of any number, of any number A is negative A. So the additive inverse is always its opposite. The reciprocal or multiplicative inverse of any non-zero number A is 1/A. So the opposite or the additive inverse is the opposite sign. The reciprocal is the multiplicative inverse, or it's when you flip it and you have the fraction. All right, I'm going to pause for a second and fill these in. Okay, so let's talk about these properties. These are properties you have seen and you have used them a lot, with the exception of this one, the closed set. So a closure, what that property tells you is that if you are adding numbers, if they are, the outcome is always going to be a value that's represented in that set, then it's considered a closed set. So if I'm adding numbers together, then they're going to give me rational numbers. So if this is a rational number, that's a rational number, or I should say real numbers, then it's always going to give me a real number. So it would be a closed set. And the same as a times b. Now we can't get that with subtraction, and we cannot get that from division because they could change on us. The commutative is the order. Order changes without the outcome. Associative is your grouping. The identity, what you start off with is what you end with. And the same with the multiplicative identity, what you start off with is what you end with. The inverse, this is where we're getting the, we're using the opposite. And so a plus its opposite, negative a, is 0. A times its inverse, 1 over a, is 1. And then we have the distributive property. So all of these properties allow us to do the math that we need to do in Algebra 2, and pre-calculus, calculus. So even though you've learned these properties before, it's still relevant to go over them in these advanced classes because they still exist. All right, so for number 13, tell which property is illustrated by each equation. So I have pi plus 7, and then I have 7 plus 5. What changed? It's exact same terms, but they switched their order. They switched their order, so this is commutative. Now, I'm going to be a little bit more relaxed on this, and I'm going to let you say commutative and be done with it. Some people will require you to say commutative property of, this is addition, so property of addition. It's addition, I know it's commutative property of addition. You don't have to tell me that. For 14, we have 1/3 plus the grouping 2/3 plus m. And then over here, we have 1/3 plus 2/3 plus m. Okay, so over here I had 2/3 and m in the group, and here I have 1/3 and 2/3. So my grouping changed. So then that's my associative. Square root of 8 times 1 equals the square root of 8. So what I started with is what I ended up with. So that's going to be my identity. Pi times the expression m plus n is equal to pi m plus pi n. That is going to be distributive. Okay, I'm going to go ahead and stop now just to break this video up, to give you guys a break.